Hi guys, BuildZoid here, and today I finally emptied out the PO box, so I figured I'd do a video just going through all of the different hardware that showed up. So yeah, let's start with it. I got my multimeter because apparently, well, a lot of this stuff came as just like bare PCBs, and I have a suspicion that a lot of it straight up just doesn't work. So anyway, let's get on with it. Card number one. So this is obviously a Sapphire card. We can see the Sapphire sticker on the IO here. This is I assume a 290X. Do we have a label? Do we? Okay, no, this is just a regular 290. Okay, so I'm assuming this thing does not work for some reason or another. So we're just going to grab our multimeter here and do a really basic check. We're just going to check that, say, our core resistance is where it should be. So, it doesn't really matter which side we measure from. 3 ohms, I think that's a bit low, but it's not necessarily a problem. Memory resistance, that's in spec. Auxiliary, so this is memory controller, that's in spec, okay, so that's good. So we have the memory controller working, we have the core is good, as far as I can tell, the memory's good, the memory controller's good. So I guess this thing might actually work, unless it's like some kind of damage to the die itself, and in that case, I mean, we're just stealing the VRM, I guess. Which is actually really fiddly, because this controller over here controls that VRM over there, and so if you cut the card right there, this gets super triggered about this not being present, and I've already run into that issue with one other card. So this is not as easy as, like, I did a bunch of RX, like I have an RX 480, like 2 different RX 480 power boards. And there it's just a case of you cut the card and you feed some voltages in and the 3567B fires right up. But on these cards, you need to get this stupid thing to, like, you need to get this voltage controller to ignore that rail. So I think what I'm going to do is I'm probably going to, like, figure out how to hard mod the card while it's still assembled. So basically just feed in a bunch of voltages without the card actually plugged in, because the thing is, the boot up procedure is basically the VRM fires up, everything fires up, and then it waits for a command from the GPU core. So if the core is dead, then, you know, we'll just fire up the card and see if I can get everything to fire up. Then I'll figure out a way to disable that while the card's still assembled. Once that's disabled, which we'll have to do in that area, probably cut the thing. Anyway, last couple checks, we're just going to check if we have 12 volts. Power plane, you know, is good, so we're just going to check from the high side MOSFET here to ground, just check if they're blown or not, which they aren't. Okay. Yeah, so I don't know what's wrong with this card, because to me this looks fine. So I'm assuming this has, I mean, we could also have an issue with there is one more rail which is right here, but I don't know what that, the spec, like, what that should be on. So, yeah, I mean, well, what resistance that should have, but I guess if we check and it's too low, then it's obvious, right? What's that, 0.3 kilo ohms? That looks good. That's fine. So yeah, that doesn't look like we have anything that's actually necessarily broken on this card. We check this capacitor right here, which is the 3.3 volts rail. That's good as well. So basically, this entire card is fine. So I'm assuming if there is any damage, it's after the voltage regulators, which means this might be like a bake and pray kind of card, you know, where you basically heat up the core area and it might come back and it might not come back, or this works. Because electrically this doesn't seem to be broken. But it did come in a, like, it came in a package of other cards that was, like, really sketchily wrapped, so I assume it was dead. Because if it was a working card, then I would hope that nobody would send it, you know, wrapped in, like, a bit of newspaper. So, anyway, let's move that one out of the way. Next card. And our next victim is one of these. And I've already seen at least one video where, because there's this repair there's this guy that does repair videos on YouTube called Eli Tech or something like that. Can't remember. So he's super useful because he actually repairs stuff, like, a lot, whereas I'm just like, I can kind of repair stuff sometimes, I guess. Anyway, so he had one of these, and it was, and his had a blown auxiliary rail. So we're going to check if that's the case here. What is that? That's 82 ohms? That's not blown. That's fine. Check V-core. About 3 ohms. That's fine. Check memory. About 100 ohms. That's fine. So that all works. So that's good. So all of that works. I guess next we're just going to check the different input filtering chokes. So we have this choke here, that choke there, and we have this choke over here. There's also a 10 amp. Is that a 10 amp? No, that's a... Please don't tell me that's a 10 amp fuse. Yeah, no, we have a 10 amp fuse right there. 10 amp fuse. I mean, admittedly, it seems to be in parallel with yet more fuses, so... yeah, but actually, let's check, right? What if the card just isn't getting 12 volts? Be a pretty easy failure. Okay, well, that's fine. Damn it. Nice, easy fix. Okay, so that works. That's all good. And this should be, I think, a 390, right? Or 390X? Oh, it's a 390X. So that'd be pretty cool if we revived that, because I do have another 390X. That works. Oh, okay. Nope. These two power stages are missing. I don't know how I missed that. Right? Like, that's pretty damn obvious. There's two power stages missing, and there's a third one missing down here. So I'm assuming, since those are all gone, somebody already figured out that this had issues. I can't remember the exact pinout for these, so we're still going to go off of the... Wait. Still going to... Yeah, let's just go off the input filters. That's going to be easy. So, input filter to ground. Yeah, that's what? That's 4 mega ohms. That's fine. Input filter to ground. That's also fine. Okay, so I guess this is just an E-power candidate at this point, because, you know, we are missing a bunch of power stages. And the core resistance is fine. I assume this thing doesn't fire up, though. Which wouldn't surprise me, because the 3567B is really easy to just, like, you take a phase out, and that thing just gets triggered immediately, so it's kind of annoying. Yeah, I assume that this is just an E-power candidate, so we're just going to pull the chokes off, feed some V-core in, and, oh wait, that's not going to fire up, that's not going to fire up. Well, actually, no, we can get memory to fire up quite easily. We just need to deal with this chip right here. There's a transistor, it's probably one of these two transistors or these two transistors in this area, which actually I'm going to zoom you in for that. So, the way most so basically a lot of voltage controllers have what is known as an enable pin. And the idea of the enable pin is that if you pull that pin low, the controller stops running, which is great if there's any kind of malfunction anywhere on the card. There's going to be like a universal enable sort of connection everywhere. And if you just pull that connection low for one reason, it turns off the entire card. Everything turns off when you pull that connection low. So, basically, and normally that's done with a bunch of transistors, and so there's a couple transistors around this here voltage controller, and one or two of these transistors is going to be connected to the enable pin of that controller. Actually, it should be just one, but there's going to be a transistor connected to the enable pin. That transistor is going to pull the enable pin to ground, and that's going to disable our memory power. If we do anything to our V-core VRM that breaks the 3567B here, zoom out again. If we do anything that triggers the 3567B, the 3567B is going to shut down everything else on the card. That includes our display drive rail, the memory rail, that's the only two ones it can shut down, because it itself controls our V-core and our auxiliary rail up here, so the memory controller rail. So basically, if we're going to E-power this, you need to E-power this set, and you also need to, well, I've never gotten one of these to fire up with part of the phases missing yet, so we're going to have to E-power that, we're going to have to E-power that, and then we can manually enable the memory VRM. That's actually really easy. I've done that on other Hawaii cards, so, and it's just a case of dealing with that chip right there, and that should be a 3520 from NCP, on semiconductor. Oh no, it's a 5230. Same thing. I tend to flip numbers around in part numbers, so You know, if I say 5320 or a 5230, to me those are the same thing, unfortunately. But anyway, if you look them up, like there's a public data sheet for that chip, so we should be able to get memory VRM working no problem. And then vCore, you know, we're just going to pull all the inductors and throw an e-power on there. Same for this right here. Only issue is that now I have so many damn cards that need e-powers that, well, the thing is, I really want to, like, this has been like a project that I've not been toying with for like ages and ages. I want to build a little like single phase converter that will power things like our, say, memory controller rail right here. I just want to build a little one of those for myself so that I don't need to use like a freaking, because like I did a 290X once in the past where I had it e-powered, so vCore had a Hall of Fame power and memory was like on the 5-phase off of a 7870, and then I had a 4-phase off of, well, and then I have had a broken GTX 480 VRM powering the auxiliary rail, so that was like 3 or 4 phases as well. Basically, it was really impractical because I was using like this big freaking power boards to power rails that are this big, right? Like that's stupid. So I actually want to go and build myself a little compact little, you know, single phase VRM that can push maybe 40 amps and just use that to feed everything everywhere. Feed all of the minor rails, because otherwise it's such a massive pain because this thing's hooked up to the freaking 3567B over there. So yeah, anyway, this looks just like an e-power candidate, because evidently it seems to be like somebody already pulled off everything that was broken, I assume. Assume that's the 12 volts? No, that's ground. So that's the 12 volts tab? Yeah, that has to be, right? Yeah, that's the 12 volts tab. And the other 12 volts tab, actually that would be the PCIe one, wouldn't it? Oh no. Yeah. Okay, so this is going to get e-powered. The other one, what was with the other one? Well, something might not turn on the other one. Anyway, next card. So this, somebody evidently tried to lap this. I'm going to probably delid this. I assume, what is it? This is a GTX 560. That should be fun. The only awkward thing about this is the freaking rectangular mounting hole spacing. It's great. Awesome. We have what seems to be... Oh, it's push pins. I freaking hate push pins. See these stupid things? Hate them. Absolutely hate them. Luckily, they're easy enough to replace with screws, right? Because the holes still line up, so you just drop your own screws through those. Those are some dinky little VRM heatsinks. Is that on the controller? Like, this is... I guess this is cooling the controller. So, yeah, let's pull those push pins off. There we go. Time to get the push pins to release. Oh, these are actually pretty nice. There's a lot of motherboards where it's like the push pins really don't want to let go. And actually, I can't grab that one properly, so... Up. Okay, so those both came through. And yes! Wait, is this a... No, that has to be memory power up in the top, right? That can't be one... Yeah, that's a different choke. So what do we have? So we have a R60 or something like that. Can't really see down there. This looks like it's 600 nanohenries, so that's going to be our memory. And then we have a 6-phase vCore VRM using 360 nanohenry chokes. Also, I'm really excited, like, well, I assume Asus just uses these same MOSFETs on, like, a whole bunch of their cards, so I'm actually really, really interested to see what those are. Because for, like, these are actually really hard to get part numbers from photos for. because the part numbers on them are so damn small. Anyway, let's just check our card's condition, right? So, what do we have? Core is fine. I mean, it's reading out 1.1 ohms, but you got to understand the Fermi architecture. The GPU cores for Fermi are all extremely low resistance. Like a working GTX 590, if you have it turned off, has a core resistance, like V-core to ground resistance of 0.5 ohms. And that's fine. If it has anything else, then you might, well, like if it's like 1 to 0.5 ohms or even 0.4 on some cards. So 1.1 ohms for this, completely fine. Let's check the memory rail. I'm going to check that one from the back just because that's more convenient. And yeah, that's good. That's like, what, 83 ohms? So there's no problem with that. It's an interesting setup of capacitors right there. These large ones. I wonder if they're on V-core or on memory. Let's see. Oh, they're V-core. What about you? Also V-core. Interesting. It's pretty interesting. Neat. Anyway. Any other voltage regulators on here? We have V-core, we have memory. That seems to be working. PEX rail, I assume is that thing right there. Is that just an LDO? That might just be an LDO. Let's see. APL. Okay, yeah, that's probably an LDO of some kind. And then that looks like our BIOS chip, so we don't have to worry about that. This is probably like 5 volts or something. What's this over here? Not sure I care. So, yeah, okay, I don't know that part number. Never seen that. And then we have an APW. So that's our controller for memory power right here. So that's a APW. That's going to be Anpec Electronics. We have an APW single-phase controller for that. We have a SHE. Oh, awesome. I love you, Asus. I really love all their rebranded freaking voltage controllers. That's great. So that's some kind of Asus rebranded controller. That's going to be fun. Well, sometimes you can actually get data sheets. Like the ASP1212 actually has a public data sheet, or is it the 1211? Can't remember right now. But, yeah, so that's kind of obnoxious. This thing looks, This thing looks like it could be, like it could be fun if I get it working. I'm not sure what's wrong with it. Also, it has a bunch of fuses everywhere, so I mean, may as well check if the fuses work, right? I mean, that's I assume they work. Right. Yeah, that one's fine. That one's fine as well. And that one's also fine. So, yeah, okay, so the fuses didn't blow out. I assume then that this is one of those cards where it's like, oh, you have to bake and pray. Which really sucks. I don't like those cards because they also tend to randomly drop dead again. So, next card. Whoop. I think this works. This was from a different pack of cards, if I remember. Actually, no, there's no way this works. Yeah, there's no way in hell this works. Let me just, well, I don't like getting thermal paste on my probes, but yeah, that doesn't work. There's craters in the freaking die. Oh boy, somebody crunched this one. So, you can clearly see that die is shattered. So you can forget about repairing this, but we can probably steal the VRM off of this just because I assume this uses some like reference NVIDIA controller. Also, we have a nice backplate. But yeah, that die is completely destroyed. Nice VRM heatsink. So if I turn this into an e-power, I don't have to worry about cooling it. Actually, that's a great idea. We're going to steal this VRM and power the 390 with it. The 390X is going to run off of this. And that way, that saves me an e-power. So, yeah, anyway, next card, and I'm actually running out of space on this desk now, because, there. And here's the heatsink for that MSI card, which, I mean, I have a literal box of just random GPU heatsinks at this point. Unfortunately, the problem with these MSI heatsinks is that they're actually really low. So in terms of clearance, like I've managed to repurpose some of the heat sinks for like other cards, but this one is, yeah. The MSI ones I've not had any success because MSI has them like really quite fit to their own PCB designs. So they don't tend to fit on just any card you come across, unfortunately. Anyway, here's a fun one. So I was actually toying with the idea of e-powering a Vega for a while. So here's our candidate for e-power on Vega. So hopefully we don't need to do anything to the memory VRM. Unfortunately, if I remember, yeah, actually no, we will, because the memory VRM on this stupid thing runs off of that controller. That's another one of those international rectifier controllers. These things generally tend to be too smart for their own good, which means since we evidently have some kind of malfunction in the vCore VRM area, we're probably going to end up with that controller being really unhappy, and that means it's not going to fire up our memory rail, so we're going to need to power that as well. But we do have the... I think I'm going to use the EVGA ePower version 5 to ePower this thing, and that just turned off. So e-power this thing because, well, we get a really solid 12-phase vCore VRM, and we also get a extra rail for our memory power. These three VRMs up here are all controlled by NCP 5230s, so we can just, you know, enable pin, force those to enable, and we should be good. So let's check if our core resistance is where it should be. Well, what it should be. And, hopefully it is, because if it isn't, then we might have a problem. That looks good. See that? So it looks really low, but that's actually a functioning Vega. Yeah, 0.25, that's good. If it was less than 0.25, then we'd have maybe a problem. So we obviously have a scorch mark right here, which I assume means that one of our 12-volt power planes is completely shorted out. And probably from here. I assume this one? Yep. So, and I guess then this choke to ground? Yeah, that's no good. I mean, no real surprise. That is pretty scorched. Yeah. Anyway, let's check our other 12-volt power plane. Because obviously, it would be nice if we managed to get this card to fire up without having to replace the VRM first, because there's obviously the issue of like, well, maybe Buildzoid, you're an idiot, and when you replace the VRM, you broke it. So yeah, that rail is fine. So our top four, like these, actually, how is it? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Yeah, so these 6 phases are entirely tied to that choke, which that choke is tied to one of the 2 8-pins. I don't really care which one. That choke powers these 6 phases. Those are fine. There's nothing wrong with those, but we do have a major problem down here, and that goes through this choke. So I don't think the controller would be all that happy if we disconnected this inductor. Just because I assume what would happen is, like, it would still be able to run that. But memory power... Let's check where memory power gets its power from. I think that runs off of PCIe. If I remember my Vega stuff correctly, this should be on the PCIe slot. So, it should be there. Yeah, so that's on the PCIe slot and not on the... Yeah, okay. That's definitely on the PCIe slot. So... At this point, what we know is basically these 6 phases right here, they may not fire up. And I do hope that we don't really have a short circuit through one of them. So let's go to... Actually, no, we don't, because we already checked the core resistance. So yeah, none of these phases are... Like, since the core resistance is fine, that tells us all of these phases are fine as well, because these things are all in parallel. And if there was a single short circuit behind any of these inductors... then our entire core would look like it's shorted out as well. So that basically tells us these MOSFETs right here are probably fine, and the main issue is just that short circuit on the 12-volt power plane. So, theoretically, this might be possible to repair. Like, well, we basically need to somehow remove the short circuit in there, which it's probably gone through a couple layers of PCB, which... That's not a good thing. So, yeah, we'll see. I've had zero success trying to remove shorts so far, so I don't think this one will be any different, but who knows? I might get lucky and the damage isn't very deep, it's just surface level. And if it is just surface level, then we're going to be gold. I mean, we don't really see anything on the back of the card, so I really might get lucky here. Because the back of the card looks fine. So, yeah, we'll have to see about this. So this is just a case of remove the short circuit. Core is good. Actually, I haven't checked the HBM, but if the core is good, the HBM should be good because that's like on a totally different 12-volt power plane. So, yeah, HBM's fine, 40 ohms. So, core's good, HBM's good. Assume these rails are good just because they're not anywhere near the actual malfunction. It might be worth trying to just fire this card up by removing this inductor and then turning it and then seeing if it turns on. If it does, then that's freaking awesome because it tells us that the card functions, and we would be running off of only like half the VRM. And after that, we can work on removing the short circuit and then replace this inductor back onto the card, and then we actually have a working card. In worst case scenario, we might lose we could lose one phase or all of the phases in that area. Which is also why I'm like already considering the idea of, hey, we might just e-power this because, well, that's one thing I've wanted to mess around with is just like, what would happen if Vega wasn't stuck with voltage control through AMD's silly software, right? Like, the e-power doesn't have a power limit, so after that, we could really just like go to town. Also, this is an unmolded die, so hopefully, I think this has SK Hynix memory, and hopefully this stuff behaves differently with liquid nitrogen than the Samsung HBM, because if you've seen what happens with in some of my live streams with Vega on LN2, basically once you go below a low enough temperature, the temperature sensors on the Samsung HBM bug out and you lose a bunch of performance and you never get it back. So yeah, anyway, moving on to the final card. And I don't need the multimeter for this one, luckily. That's not a GTX 690. I'm really excited for this. Oh boy, that's a lot of tape. Please don't break the packaging. I don't have enough anti-static bags, so there. I want to be kind of careful with this one. There we go. Come here. Oh boy, that anti-static bag is actually a bit too small for that card. Ta-da! As far as I know, this does work. So that's good, because I don't want to like be trying to repair this. That is a card. That is one hell of a card. Now I just need to get the 295X2 and a 5970. Fortunately, I've decided, well, recently I've decided I need to stop buying more GPUs because you've just seen what I went through here, right? Like, I need to actually do stuff with all the damn cards I have before I keep buying more of them, because I'm going to end up burying myself in GPUs that don't work or do work or just, you know, varying states of functional, and yeah, it's already becoming a bit of a problem. So yeah, this is a Titan Z. I'm excited. Like, I'm really excited for this card. Damn, this is thick. It's kind of a shame that they didn't go to, like, all the way in the height, right? Like, you can see that the bracket is actually quite significantly taller than the heatsink. So, there could have been more surface area. Could have been. Not sure it would necessarily need it. We actually have some pretty impressive... So, the VRM on these cards is actually... so if you remember that power color video where I was like, I don't know why they decided to shove all of their power rails like on the edge of the card, because then you have problems like delivering power to like the core that's furthest away from them. Yeah, most dual GPU cards actually do the thing where they put the VRM right down the middle. And then they just use extra layers to route the PCIe around it or something. I'm not entirely sure how it ends up working out with the PCB layouts for those, but anyway, this has the VRM down the middle. I'm actually really excited to take this apart. We're not going to do that right now because it's going to be like its own PCB breakdown video, but that's going to be awesome. And I do intend to overclock it. I don't think I'll actually take it on like any extreme cool. Well, maybe dry ice. Maybe dry ice. But I don't really want to break one of these because, well, even now they go for around $500, so they're pretty damn expensive, and they're kind of rare. relatively speaking. So yeah, that's a Titan Z. I wonder, actually, I should get another one. Well, nah, I won't bother with SLI for this. Maybe once Titan Z's are like $100, I'll pick up another one and we can do an SLI build, do like a quad SLI setup with it. But damn, like I'm excited for the PCB breakdown of this. I do want to mod this. Like, I want to do the same kind of thing with this that I did to, like, the GTX 590s, so I think the backplate won't be able to stay. Which is kind of a shame, because this is a pretty nice backplate. But it's just, like, I won't have any space to work if I keep that on there, and there's going to be even less space on the front of the card. So, yeah, that's it for this, well, it's not really a mail, well, it kind of is a mailbag, right? Like, emptied out the P.O. box, went through all the stuff that came in. Huge thanks to all of the people that sent cards in. If you're one of the people who sent something in and I didn't give you a Discord link, then send me an email, because you already have my email because you sent these cards somehow. So, yeah, Discord, basically what I'm doing is, like, the Discord is for both Patreons and also anybody who sends anything in, just because, well, I don't have a better, like, because of that, like, it's just kind of awkward to me that, you know, Patreons are the only one who get, like, reward tiers, which is kind of why I don't do reward tiers. Anyway, yeah, huge thanks to everybody who sent in cards. Please don't send any more stuff. I need to get through this pile of hardware. The funny thing is, I don't even, like, the worst part is, like, the GTX 560, the 2 Sapphire cards, I have no idea who sent those in. So, yeah. I think in terms of order of cards I'm going to work on the Vega first. Just because I think that might be the easiest one to try fix. Then I'm going to work on the GTX 980 Ti, where we're just going to steal the VRM. After that, maybe the GTX 560s. But the thing is, like, don't expect any more content with these anytime soon, because I still need to get through a bunch of stuff with the 9900K, and I recently got a new memory kit that I need to test, and yeah, I'm just flooded with hardware to work on. Anyway, huge thanks to everybody who sent cards in, and I'm not gonna even bother going with, like, hey, you can support me on Patreon or whatever, because yeah, I've just got, like, way too much hardware for free. I honestly feel bad about this, because I'm not gonna turn this into content for like a couple months. Oh boy. Anyway, thanks for watching, and I'll stop the video here. So goodbye.